Hey everyone, welcome to another deep dive. Today we're diving into coastal waters and ocean currents. Like how those amazing beaches we love are shaped by some seriously powerful forces. Got our trusty sources right here, coastal waters and shoreline features, and Introduction to Oceanography. Let's do this.
You're going to be amazed how this stuff connects to everything. What you eat, the air you breathe, ecology, geology, even climate change. The whole shebang.
Okay, so picture this. You're on a beach, sun's warm, sand between your toes, maybe some dramatic cliffs in the distance.
You've got it. You're standing in what we call a coastal zone. It's this constant push and pull between land and sea shaped by incredible natural forces, and that's what we're going to unpack today.
And it's not just about the sand and waves, right? We're talking entire ecosystems under the surface. Coral reefs, estuaries, salt marshes, mangroves. They're all connected, but I gotta admit, I don't fully get how it all works.
It's a delicate balance, that's for sure. But let's start with one of the most important and sadly most threatened ecosystems. Coral
Ah,
reefs. Think of them like underwater cities, absolutely teeming with life.
I've heard them called the rainforests of the ocean, right?
Exactly. And just like rainforests, they're incredibly important for biodiversity, but they're also crucial for us humans, too.
Okay, break it down for me. Why are coral reefs so important?
Well, for starters, they're built by these tiny animals called corals. They secrete calcium carbonate. Basically, they build their own homes, and those homes provide shelter and food for this mind-blowing diversity of marine life. It's like a bustling underwater city down there. But it's not just about the fish. Coral reefs protect coastlines from erosion. They're a source of food and income for millions of people through things like fishing and tourism. And get this, they even hold potential for medical breakthroughs.
Medical breakthroughs. Now, that's something you don't hear every day.
It's true. Researchers are studying them for all sorts of things, from painkillers to even cancer treatments. But sadly, they're in serious danger. Pollution, overfishing, and climate change are pushing them to the brink. You've probably seen pictures of bleached coral, right?
Yeah, they look almost ghostly white, like
Wow.
they're dead.
And tragically, that's what's happening. Coral has this amazing symbiotic relationship with algae called zooxanthellae. These tiny algae live inside the coral, providing it with food and giving it those vibrant colors we see. But when the water gets too warm or the coral gets stressed from pollution, it basically kicks out the algae, leading to that bleaching effect.
So it's like the coral is losing its food source and its color at the same time.
Exactly. And if that stress continues, the coral can actually die, and that has devastating consequences for all the marine life that depends on the reef.
It really puts into perspective how interconnected everything is. Something that seems so far removed from our daily lives can have huge ripple effects.
Absolutely. If we connect this to the bigger picture, coral reefs are like a warning sign. Their decline tells us something's wrong with the overall health of our planet. We need to protect them, not just for the reefs themselves, but for the health of our oceans and ourselves. But hey, let's not dwell on the doom and gloom. There are ways to help, and it all starts with understanding how vital these ecosystems really are.
All right, so we've talked about coral reefs. What about those other fascinating coastal areas? Estuaries, for example. I've always been intrigued by them, where the river meets the sea, right?
You got it. Estuaries are these partially enclosed bodies of water where fresh water mixes with salt water. It creates this unique, brackish environment that supports a whole other cast of characters.
So it's like a mixing pot of species.
Exactly. You've got freshwater species, saltwater species, and even some that are specifically adapted to that brackish environment. And because of that mix, estuaries are incredibly productive ecosystems. They serve as nurseries for many fish species, offering a safe haven where they can grow before heading out into the open ocean.
And they provide other benefits too, don't they?
Oh, they're like multitasking superheroes.
Hmm.
They help filter out pollutants from the water, they act as natural buffers against storms and erosion, and they provide all sorts of recreational opportunities for us humans, boating, fishing, kayaking, you name it.
Okay, so estuaries are clearly essential. What about those other features we see along the coast? Beaches, for example. How are those constantly shifting piles of sand created?
Beaches are fascinating. They're constantly being shaped by waves, tides, and currents. Imagine those crashing waves carrying sand particles, grinding them down, depositing them along the shore. That's how you get that beautiful beach you're picturing.
So it's like the ocean is constantly sculpting the coastline.
Exactly. And those currents you mentioned play a huge role. You've got longshore currents, which move parallel to the shore, transporting sand and shaping the beaches we see.
So if you see a sandbar appearing or disappearing, that's the ocean currents at work.
You got it. And we can't forget about barrier islands, those long, narrow strips of land that run parallel to the coast. They act like bodyguards, protecting the mainland from the full force of storms and erosion.
Barrier Islands always seem so mysterious to me. Like, how did they even get there?
Well, they form over time. Waves and tides deposit sand and sediment, and slowly but surely they build up these natural barriers. And they're not just piles of sand, they often support dunes, marshes, and diverse ecosystems of their own. Speaking of fascinating formations, let's dive into the broader world of oceanography itself. It's the science of everything ocean, from the creatures that live there to the currents we've been talking about, the seafloor, the chemistry, you name it.
It's like the ocean is its own universe, full of mysteries to unravel.
Exactly. And one of the biggest mysteries is how the oceans even formed in the first place. Early theories thought the Earth was once this molten ball of fire. As it cooled, water vapor was released, forming the oceans.
That's a pretty dramatic origin story.
It is. But modern theories suggest something even more mind-blowing. They think the Earth was formed from cosmic dust and these things called planetesimals. Water was trapped inside these early building blocks and released over time through volcanic eruptions and what's called outgassing.
So the oceans literally came from inside the Earth.
Pretty amazing, right? And then there's the question of why the ocean is salty. It wasn't always this way, you know?
I have to admit, I've always wondered about that. I mean, it's salt water, but rivers are fresh water. Where does it all come from?
Well, the early oceans were actually a bit acidic, and this acidity helped them dissolve minerals from rocks. Over time, this process, along with rivers carrying dissolved salts from land and hydrothermal vents releasing minerals from deep within the earth, made the oceans salty.
So it's like a giant salty soup seasoned over millions of years.
Exactly. And speaking of soup, let's stir things up a bit and dive into ocean layers. The ocean isn't just one big, uniform body of water. It's stacked in these distinct layers, each with its own unique personality. It's like traveling to different worlds without ever leaving the planet.
Okay, I'm intrigued. Take us on a journey through these layers. Where do we start?
We'll start our adventure in the epipelagic zone. That's the top layer where the sunlight shines through. This is the ocean most of us are familiar with, teeming with life, fish, whales, dolphins, sea turtles, all soaking up the sun's rays.
It's like the bustling city center of the ocean, full of life and vibrant colors.
Perfect analogy. But as we go deeper, the light starts to fade, and we enter the twilight zone, also known as the mesopelagic zone. Things get a little spooky here. The light is dim, and many creatures here have actually evolved bioluminescence. They create their own light.
Okay, now that's just cool, like something out of a sci-fi movie. What's the point of making your own light down there, though?
Survival. Down in the twilight zone, it's all about attracting mates, luring prey, or even confusing predators. It's a world of flashing lights and shadowy figures.
So what lies even deeper? Does anything even live where there's no light at all?
Oh, absolutely. As we plunge further into the abyss, we enter the bathypelagic zone. We also call this the midnight zone. The pressure is immense, the water is freezing cold, and there's absolutely zero sunlight. Yet, life finds a way.
This is blowing my mind. What kind of creatures can survive in such a harsh environment?
We're talking creatures with unbelievable adaptations. Giant squid with eyes the size of dinner plates, anglerfish with bioluminescent lures dangling in front of their mouths, and all sorts of bizarre, gelatinous creatures that look like they're straight out of a science fiction novel.
Okay, you're really making me want to watch a deep-sea documentary now.
They're incredible, aren't they? But we're not done yet. Our journey takes us even deeper, to the abyssopelagic zone, or as we sometimes call it, the abyss.
The abyss. That sounds ominous.
It is a place of extremes. The pressure here is crushing, the temperatures are near freezing, and life is scarce. But it does exist, which is a testament to the incredible resilience of life on Earth.
And after the abyss, is there anywhere else to go?
Believe it or not, yes. At the very bottom of the ocean, nestled within the deepest trenches, lies the Hadal Pelagic Zone. This is the ocean's final frontier. The Mariana Trench, for example, plunges deeper than Mount Everest is tall.
That's insane, anything living down there.
You bet. Even in this extreme environment, we find life. It's incredible what creatures can adapt to. But before we get completely lost in the depths, let's switch gears and talk about something that connects all these layers of ocean currents. These underwater rivers, they're like the lifeblood of our planet.
Okay, I'm ready to ride the current. Tell me more.
Well, ocean currents are these continuous directed movements of seawater driven by this complex interplay of factors. We're talking wind, Earth's rotation, temperature differences, even the saltiness of the water. It's like this giant interconnected web constantly moving water around the globe.
So what's driving this global watery dance?
Great question. When we look at the big picture, the major surface currents, those ones we see on maps, actually move in giant circles called gyres. These gyres move clockwise in the northern hemisphere and counterclockwise in the southern hemisphere.
Why the different directions?
That's all thanks to something called the Coriolis effect. It's a fancy way of saying that the Earth's rotation deflects moving objects. And those swirling gyres, they're not just pretty patterns on a map, they're actually redistributing heat from the equator towards the poles.
So ocean currents are like Earth's natural air conditioning system.
You could say that. They help regulate global temperatures, prevent the tropics from getting too hot and the poles from getting too cold. They influence weather patterns, rainfall, even the formation of storms.
Wow, they're like the conductors of the planet's weather orchestra.
And then we have the deep ocean currents, often driven by something called thermohaline circulation. Imagine a giant conveyor belt moving water around the planet. That's thermohaline circulation in a nutshell.
Okay, you've definitely got my attention. Tell me more about this underwater conveyor belt.
Well, it all starts with cold, salty water sinking in the polar regions. As this denser water sinks, it travels along the ocean floor, creating those deep ocean currents. Meanwhile, warmer, less salty water from the tropics flows toward the poles to replace the sinking water, creating surface currents. This continuous loop plays a crucial role in regulating Earth's climate.
Well, it's like a giant slow-motion dance. Warm water flowing up, cold water sinking down.
Exactly. But here's the thing. This delicate dance is being disrupted.
Wait, disrupted? How so?
Climate change. As global temperatures rise and glaciers melt at an alarming rate, huge amounts of fresh water are pouring into the oceans, especially in the North Atlantic. This influx of fresh water is messing with the salinity, making the water less dense, and potentially slowing down or even disrupting this vital circulation system.
Okay, that sounds bad. What would happen if this underwater conveyor belt stopped altogether?
That's the million-dollar question, and it's what has scientists seriously concerned. We're talking potentially catastrophic consequences for the planet. Europe could be plunged into a deep freeze, weather patterns worldwide could be thrown out of whack, and marine ecosystems could be devastated.
Wow, this is definitely a deep dive into some heavy stuff. So these ocean currents are clearly essential to, well, pretty much everything.
They're the unsung heroes of our planet. And speaking of powerful forces, we can't forget about tides.
Ah, yes, tides. Those daily rises and falls of the ocean that dictate when we can go for a swim or build a sandcastle. But what actually causes them? I mean, I know it has something to do with the moon, but how does that work exactly?
You're right, the moon is the maestro of the tides, and it all boils down to gravity. Imagine the moon's gravity like an invisible hand gently tugging at the Earth's oceans. This pull creates a bulge of water on the side of Earth facing the moon.
So the moon is literally pulling the water towards it.
Precisely. And because of inertia, that tendency of an object to resist changes in motion, a bulge also forms on the opposite side of the Earth. These bulges are what we experience as high tides.
Wow, so the moon is basically playing tug of war with our oceans.
In a way, yes. Now, as the Earth rotates, different locations pass through these bulges, causing that regular cycle of high and low tides we experience. Most coastal areas experience 2 high tides and 2 low tides each day.
So it's like a giant watery dance floor, with the moon leading and the oceans following.
And it gets even more intricate. The sun's gravity also plays a role in the tides, though it's not as strong as the moon's pull because it's much farther away. When the sun, earth, and moon align during a full moon or a new moon, their gravitational forces combine to create especially high tides called spring tides.
So the ocean gets extra stretchy during those times.
You could say that. And then there are neap tides, which occur when the sun, earth, and moon form a right angle. During neap tides, the sun's gravity partially counteracts the moon's pull, resulting in less extreme high and low tides.
So it's like a cosmic balancing act between the sun and the moon.
Exactly. But tides aren't just about these dramatic rises and falls of the sea level. They have a huge impact on coastal ecosystems, too.
Okay, now this is where my brain starts to hurt a bit. How do tides shape life in the ocean?
Well, think about it. Imagine those areas of the coastline that are submerged at high tide and exposed at low tide. We call them intertidal zones. The creatures that live there have to be incredibly adaptable to survive those constantly changing conditions.
It's like living in 2 different worlds. One minute you're underwater, the next you're high and dry.
Precisely. So they've developed some incredible adaptations to cope. Barnacles, for example, have these super strong plates that they can close up tight to prevent themselves from drying out when the tide is low. Mussels use these tough, stringy fibers called byssal threads to anchor themselves to rocks so they don't get swept away by the waves.
That's incredible. They've evolved to thrive in this constantly changing environment.
Exactly. And it's not just the creatures. Tides also influence the physical structure of these ecosystems. They create channels, mudflats, salt marshes, this whole range of habitats that support an incredible diversity of life. They also play a crucial role in transporting nutrients, oxygen, and even larvae, shaping the food web and influencing the overall health of coastal ecosystems.
Oh, this really is a deep dive. It's amazing how something we often take for granted, like the tides, can be so complex and so important for life on Earth.
It's a reminder that even the seemingly simple things in nature are often governed by these incredible forces and connections that we're only just beginning to understand.
It is a lot to take in. But before we get too far away from it, right before the break, things were getting intense with the whole idea of this giant ocean current system shutting down.
Mhm.
Sounds like something out of a movie.
It might sound far-fetched, but it's a very real concern. Remember that underwater conveyor belt we were talking about, the thermohaline circulation? It plays a critical role in regulating Earth's climate. And scientists are seeing warning signs. It seems to be weakening.
So how could something so massive be affected by us? Are we really that powerful?
It's not really about raw power. It's more about disrupting delicate balances that have been in place for a very long time. Think about it. The ocean absorbs a massive amount of the excess heat that's trapped by those greenhouse gases. And, because of climate change, as temperatures rise globally, the oceans are warming too. And that warmer water is less dense, so it doesn't sink as easily. It kind of throws that whole sinking and rising cycle that drives the thermohaline circulation out of whack.
And on top of that, we're dumping all that fresh water from melting glaciers, particularly into the North Atlantic. And you said that messes with the salinity too, right? It's like we're tinkering with a perfectly tuned engine and then wondering why it's sputtering.
That is a great analogy. It's like we're diluting the fuel that keeps this massive current system going.
Okay, so we've messed things up. That much is clear. But paint me a picture here. What would a world with a disrupted AMOC, that's Atlantic Meridional Overturning Circulation, right?
Right.
What would that world actually look like?
Well, it wouldn't be pretty, that's for sure. Europe, for example, is actually warmer than it should be, given how far north it is. And that's largely because of the heat transported by the North Atlantic Current, which is part of that AMOC system. If that current weakens or shuts down, Europe could see much colder winters, shorter growing seasons, and all the chaos that comes with that kind of climate shift.
So we're not just talking about a few extra snow days. We're talking potential for massive disruptions to things like agriculture, energy consumption, even migration patterns.
Absolutely.
Right.
And it wouldn't just be Europe. This is a global system we're talking about. Disruptions in one area can have ripple effects across the planet. We could see changes in rainfall, more extreme weather events like massive hurricanes and droughts, even shifts in marine ecosystems that affect fish populations, which would be devastating for the people who rely on them.
It's like a terrifying domino effect.
Ah.
One thing knocks into another and boom, suddenly the whole system's in chaos.
That's one way to put it, yeah. Whether we realize it or not, we are completely connected to the ocean, even if we live thousands of miles inland.
Okay, so the potential consequences are clearly huge. But is there any good news here? Is there anything we can do to prevent this shutdown, or at least try to minimize the damage?
Well, the good news is that this isn't a hopeless situation. The future isn't set in stone. But we need action, and we need it now. The key is addressing the root cause, climate change.
Okay, so that means reducing our greenhouse gas emissions, switching to cleaner energy sources, and just generally being more mindful of our impact on the planet. But those are huge systemic changes. How can we, as individuals, even make a dent in a problem that big?
I know, it's easy to feel overwhelmed by the scale of it all, but trust me, every little bit helps. Don't underestimate the power of collective action. Start by making changes in your own life. Reduce your carbon footprint. Drive less, fly less, choose energy-efficient appliances. Support those businesses and organizations that are truly committed to sustainability.
And use your voice. Vote for leaders who actually take climate change seriously. Support policies that promote clean energy and protect the environment.
Exactly. Education is also key here. The more people who understand how interconnected these systems are and how urgent this problem is, the better equipped we'll be to find solutions.
All right, so we know we need to act on climate change. That's a given. But in the meantime, are there other things we can do specifically to protect ocean currents or maybe mitigate some of the damage that's already been done?
That's a great question, and it's something scientists are looking into. There are ideas out there like large-scale ocean fertilization projects to try and stimulate phytoplankton growth. The idea is that this could help absorb more carbon dioxide from the atmosphere, but a lot of these geoengineering solutions are pretty controversial. They come with their own set of risks and uncertainties.
So it's not just a matter of finding a quick fix. We have to carefully consider the potential consequences of any action we take, especially on such a large scale.
Exactly. We need to be cautious and focus on those solutions that address the problem at its core, which is climate change. But we also need to be open to exploring ways to make the ocean more resilient.
That makes sense. We've been talking about the global impacts of ocean currents, but I want to zoom back in on a more individual level for a moment. We were discussing rip currents earlier and how dangerous they can be for swimmers.
Yes, it's so important to be aware of those.
So if someone's listening and they're heading to the beach, what are some things they should look out for to stay safe?
That's a great question. First and foremost, always swim at a beach with lifeguards. And always, always pay attention to any warnings they post. Rip currents can form very quickly, even on a seemingly calm day.
So even if the waves don't look that big, you could still get caught in a rip.
Oh, absolutely. One way to spot a rip current is to look for a break in the wave pattern. If you see an area where the waves aren't breaking as much or the water seems to be turning out towards the open ocean, that's a big red flag. The water might also look darker or murkier in a rip current.
Okay, so those are all good things to watch out for. But what if you do get caught in a rip current? What's the best course of action?
The most important thing is don't panic. Easier said than done, I know, but fighting against the current will only wear you out.
So what should you do?
The key is to swim parallel to the shore, not directly towards it. Swim out of the current, and once you're free from its pull, then you can swim back to shore at an angle.
So it's kind of like escaping a river current. Swim to the side until you're out of that strongest flow.
Exactly. It's also a good idea to wave your arms and yell for help if you can. Lifeguards are trained to spot people caught in rip currents and can come to the rescue.
This is such crucial information for anyone spending time at the coast. Ocean currents are incredibly powerful forces, but understanding how they work can quite literally be a lifesaver.
It's all about respecting the ocean's power and being aware of your surroundings.
All right, so we've covered a lot of ground today. We've gone from the global impacts of ocean currents on the climate to the very real dangers of rip currents at the beach.
It is a lot to take in.
It is. But it's also incredibly fascinating. And it highlights how important it is to protect these incredible forces of nature. We've only scratched the surface of this topic. There's so much more to explore. Speaking of exploring, before we wrap up, I want to dive a bit deeper into one of the ocean's most mysterious realms, the twilight zone.
Ah, the Twilight Zone, a place of wonder and strange beauty.
You mentioned earlier that it's home to the largest migration on Earth. Tell me more about that.
Okay, so picture this. Every single day, trillions, yes, trillions with a T of creatures, from fish to squid, crustaceans, you name it, they're all migrating vertically in the water column. During the day, they stay in the dim depths of the Twilight Zone, hiding from those predators that hunt by sight. But as the sun begins to set, they make their move, swimming thousands of feet up to the surface waters to feed.
It's like this giant reverse commute, up all night, down during the day.
Exactly. It's this incredible spectacle driven by the availability of food and, of course, the need to avoid becoming someone else's dinner. And it's all happening right under our noses, largely unseen and understudied.
So why haven't we explored this massive migration more? Why don't we know more about the Twilight Zone in general?
Well, exploring the deep ocean is challenging and expensive. It requires specialized equipment, remotely operated vehicles, or ROVs and submersibles that can handle the intense pressure and darkness down there. And the Twilight Zone itself is vast and tough to study. It's like trying to track a swarm of bees in a dimly lit cathedral.
But despite those challenges, scientists are making incredible discoveries down there.
Absolutely. Every expedition into the Twilight Zone brings back new species, bizarre adaptations, and gives us a better understanding of this critical part of the ocean ecosystem.
It sounds like there's still so much we don't know. What are some of the big questions scientists are hoping to answer about the Twilight Zone?
Well, we're still trying to figure out exactly how many creatures live down there and what their role is in that whole ocean food web. We also want to know how climate change is impacting the Twilight Zone. Things like rising temperatures, ocean acidification, changes in oxygen levels, these could all have huge effects on these deep sea ecosystems.
Really makes you think, huh, there are these massive events, these movements of life happening in the ocean that we're totally clueless about. It just shows you how much we still have to learn about what's going on down there.
Absolutely. And the twilight zone, it's just one piece of the puzzle, right?
Yeah.
It seems like every time we look at a new part of the ocean, we discover something totally new and unexpected.
Makes you wonder what else is out there. Okay, so we've covered a ton of ground in this deep dive, from those tiny creatures in the deepest parts of the ocean to those massive currents that circle the globe.
We've seen how these forces shape the planet, how they control the climate, and how they support this incredible web of life. But we've also seen the flip side, how human actions are really impacting these systems, and not always in a good way.
Yeah, it's definitely something to think about, but it's also a call to action. We can make a difference, we can protect the oceans, and make sure our planet stays healthy.
I completely agree, and it all starts with understanding. The more we learn about the ocean, the more we understand its importance, and the better we'll be at protecting it.
So to everyone listening, we hope this deep dive has piqued your curiosity and maybe even inspired you to learn a bit more about this incredible planet we call home. Keep exploring, keep asking those questions, and most importantly, keep speaking up for the protection of our oceans.
The future of our planet really depends on it.
Couldn't have said it better myself. And on that note, we'll wrap up this deep dive. Thanks for joining us, and we'll catch you next time for another exciting exploration into the natural world.